Hey guys, here's a video that goes over the Unit 5 material, and it follows the blue study guide I handed out in class. All right, so first question, you've got negative 3x, 2x plus 4. Distributive property, that means negative 3x times 2x, which is the same thing as negative 3 times 2 times x times x, which is negative 6x squared. And you could just jump straight from here to here going forward. Same thing right here. Negative 3x times 4, negative 3x times 4, same thing as negative 3 times 4 times x, which is negative 12x. Okay, now here's one for you to try. Negative 4x, negative x minus 8. Okay, so negative times a negative makes that a positive. We've got x and x, that's going to make x squared. Negative times a negative makes that a positive. 4 times 8 is 32, and we've got 32x. Okay, question number 2. You have this 3x minus 1, 2x plus 3. Now for this one, best way to do this is to draw a box. And we're going to do 3x minus 1 and 2x and 3. Now this is going to come into here, and this is going to come into here. We're going to multiply them together. So 3 times 2 gives you 6. X and x make that 2 x's in there. All right, now we have 2x times negative 1. So a positive times a negative is going to be a negative 2x. Then right here, the 3x is going to come down into here. This is going to come over there. So 3 times 3 is 9, and then we got the x. And then finally, 3 times negative 1 is negative 3. Now, when you write your answer, you could write 6x squared minus 2x plus 9x minus 3, but you might notice 9x and 2x, these are the same type of animal, so we can combine those together. So the way you need to write this is 6x squared plus 7x minus 3. That's your final answer. Okay, I want you to give this one a try on your own. Go ahead and pause the video and try this one on your study guide. Okay, so we multiply that and that. Let's do this with a box, actually. So you've got your box. Got your 2x1, you have your 5x and the minus 4. That's going to give you 10x squared. That's 5x. That's negative 8x, and that's negative 4. Combining these ones, you end up with 10x squared minus 3x minus 4. Okay, let's go ahead and do the next one. Question number 3. Question number 3, we've got 2x, 4x minus 1, minus 3, 4x minus 1. And we are doing some distributive property first. And when we do the distributive property, that's going to give us 8x squared minus 2x. Distributive property here, that's going to give us minus 12x. And be careful of this one, negative 3 times negative 1 is positive 3. Combining these ones, which are like terms, is going to give us 8x squared minus 14x plus 3. All right, let's try this one. We got 3x, 2x plus 1, minus 5, 2x plus 1. Go ahead and pause the video, give this one a try. All right, distributive property right here is going to give you 6x squared plus 3x. Distributive property here, negative times a positive, negative 5 times positive 2, and then negative 5 times positive 1, negative 5. Combining like terms, we've got 6x squared minus 7x minus 5. Okay, moving on to question 4, domain and range. So for these ones, we've got these graphs, and this one is going to look like this. Kind of like that. And the first question is asking about the domain. Now the domain, kind of think about this in terms of a box. If I was to box this thing up, let's kind of put a box around it. Domain is how far to the left and how far to the right the box goes. So if you look on your graph, this right here is going to be a negative 2 right there, and on your graph, this right there is going to be a positive 1. And so for the domain, you're going to say negative 2 comma 1. Now the other part of this is if this is a filled in circle, then this gets a squared bracket. Because this is an open circle, it gets a rounded parentheses. Now for the range. The range is how low we go and then how high we go. And here we're looking at just the y values. And so the y value down here is negative 5. The y value here is 3, but the y value up here is 4. So the range is the lowest we go, which is negative 5. This thing goes all the way up to 4 and then back down again. Now, that doesn't matter that it goes back down. The thing that matters is that the highest point achieved was 4. Now, negative 5, because this is filled in, this gets a square bracket. Now, up here at 4, there's no circle, right? There's not an open circle or a closed circle. When it's something like this, when a curve hits a value and then drops down again, we give it the value that it bumps into. So we're going to say it did get to a 4, even though we couldn't tell the difference by looking at this, whether it got to 3.9999. We'll just say that if it gets to a value and goes back down again, it will actually hit the value, and we'll give it that square bracket. Okay, let me give one to you to try. Let's say you got something like this. This is filled in, and it goes like that. And this is 2, and this is negative 1, and this is 4. Okay, go ahead and figure out the domain range. Pause the video, give it a try. Okay, so domain is going to be negative 1 to 2. Negative 1 is a filled-in circle, square bracket. 2 is open, surrounded. Now, the range is where a lot of people are going to make mistakes. For the range, you think of the lowest y value. So here it's negative 5, negative 4, negative 3, negative 2, negative 1. This is at 0. So the y value here is at 0. That's the lowest y value is 0. And then 1, 2, 3, 4. The highest y value is 4. So it's 0 to 4 with the square bracket. Just remember, when you're thinking of the range, you're thinking of y values. And the lowest y value here is 0. Okay, now let's move along. Number 5 on the study guide says, when you look at a table, how do you know if it's a function or not? So I have x and y. If this is 3, 4, 5, 3, and this is 8, 9, 10, and this is 13, this would not be a function. And the reason it would not be a function is because 3 gives you 8, 4 gives you 9, 5 gives you 10, but 3 also gives you 13. So a single x value, namely 3, is giving you 2 different and conflicting y values. So on your study guide at number 5, when it says, when looking at a table, how do you know if it's a function? It is if there are repeated x values. So repeated x values means not a function. Okay, you can have repeated y values, but it's repeated x values that are the problem. Okay, so question 6, it'll say something like this. You have this relation that is defined as 1 comma 3, 2 comma 4, 7 comma negative 3, 2 comma 1, and negative 2 comma 7. And it's asked for the domain. Domain is just the x values, so we just list them 1 comma 2 comma 7 comma 2 comma negative 2. Go out and take out any duplicates. Here the duplicate is 2. So you would just write in 1, 2, 7, negative 2. Now for the range is going to be all the y values, which is 3, comma 4, comma negative 3, comma 1, comma 7. There aren't any duplicates here, and so the range is done. Now the question asks, is this a function? And the answer to that is no, because of that repeated x value. Okay, go ahead and do the next one on your own. Let me write it out. Range is equal to negative 2 comma 3, 4 comma 4, 5 comma negative 5, negative 7 comma 1, negative 3 comma 4. Okay, as for the domain, I'm not going to write this, but the domain is going to be negative 2, 4, 5, negative 7, negative 3. There's no repeats. The range is going to be 3, comma 4, comma negative 5, comma 1, comma 4, but you cross off that second 4 because that 4 is a repeater. And is this a function? Answer is yes, because there's no repeated x values. Repeated y values are fine, but repeated x values means it's not a function. Okay, next question. When you look at a graph, how do you know if it's a function or not? And it's something called the vertical line test. So what does that mean? Question 8. Is this a function? Answer is no, because the vertical line slices through in 2 points. A single x value, let's say this x value is like 2, has 2 different y values, right? So 2 goes into the table. If this is x and this is y, 2 goes in, and 2 gives me 7. And 2 goes in, and 2 gives me 9. So a single x value gives me 2 different y values. Okay, so basically vertical line test. What about something like this? This is okay, because a vertical line touches in 1 point. What about a circle? Circle is not a function because a vertical line touches in 2 points. All right, flip it over, back of the study guide. Greatest common factor. If you have 4x to the 5th plus 20x to the 4th plus 12x cubed, how do you know if this, or how do you know what the greatest common factor is? Let's do this the long way, then we'll do it the short way. 4 is the same thing as 2 times 2. X to the 5th is 5 of those x's. Now 20x to the 4th. What's 20? Let's do this off to the side. 20, if we break it down, 20 is the same thing as 2 times 10, and that's 2 and 5. So 20 is 2 times 2 times 5, x times x times x times x. And then 12, let's see, if we break down 12, 12 is 2 times 6, and that's 2 and 3. So 12 is 2 times 2 times 3 times x times x times x. Now you look at these and say, what do these all have in common? They all have a 2 in common. They all have another 2 in common. They all have an x and an x and an x. They have 3 x's in common. And so the greatest common factor for all of those terms will be 4. 2 and 2 is 4, x cubed. Now, what's the fast way? The fast way is you look at this and say, what does 4, 20, and 12 divide evenly by? I can divide them all by 2, because 4 divided by 2 is even, 20 divided by 2 is even, 12 divided by 2 is even. Let's go higher than 2. Can I divide them all by 3? No, because 4 doesn't divide by 3. Can I divide them all by 4? And the answer to that is yes. 4 divided by 4 is 4, 20 divided by 4, 12, I can all divide them by 4. So 4 is the greatest common factor of that, that, and that. And then I also say, which has the fewest number of x's? This has the fewest number of x's, so 4x cubed. All right, let's do this one with the fast method. You've got 3x squared plus 15x to the 4th plus 9x cubed. Think of what the greatest common factor is. All right, what can you divide them all evenly by? You can divide them all evenly by 3. They all can divide by 3. What's the fewest number of x's? It's going to be x squared. So the greatest common factor is 3x squared. All right, pretty fast, right? Let's go ahead and do this one on your own. 15x to the 5th plus 20x to the 4th plus 10x to the 6th. What can you divide 15, 20, and 10 by? You can divide them all by 5. Fewest number of x's is 4, so 5x to the 4th is the greatest common factor. All right, question number 10 on the study guide. Linear, exponential, quadratic. How do you tell it's linear? If it's linear, it has a common difference. Okay, an example of that is like 5, 7, 9, 11, plus 2, plus 2, plus 2. That's the common difference. Exponential has a common ratio. An example of a common ratio would be like 5, 10, 20, 40. Timesing by 2, timesing by 2, timesing by 2. Now here the difference between 20 and 40 is not the same as the difference between 5 and 10, right? 20 and 40 are 20 apart, 5 and 10 are 5 apart. So it's not about it being a difference between the two. It's the fact that I multiplied and multiplied and multiplied. Here it's added, added, added. Common difference can also be subtract, subtract, subtract. Common ratio can also be divide, divide, divide. So if you're adding or subtracting, that is linear. If you're multiplying or dividing, that is exponential. Now, if it's not linear exponential on the quiz, it's going to be quadratic. But what is quadratic? Let's give this example. 1, 4, 9, 16. Am I adding 3? I'm not adding 3. So it's not linear because I'm not adding the same thing. Is it exponential? Let's see. Timesing by 4, timesing by... Nope, I'm not multiplying by the same thing. So let's look, though, at the difference. Difference between 1 and 4 is 3. Now, I already told you it's not going to be the same difference each time, but if you keep looking at the differences, you might notice a pattern. The pattern is this. 3, let's go one more. If this is 25, then this is 9. And now if I take the difference of the difference of the difference will remain a constant. So for quadratic, you have a common second difference. Okay, let's go down to number 11. For number 11, we've got this. F of x equals 3x, let me write that better. 3x squared minus 2x plus 2, and it's asking for f of negative 1. This is probably the hardest question on the test. And the idea behind it isn't so hard. It's just when you do it, you have to be really careful. You're going to do about like 10 different operations, and if one of them is wrong, the whole answer will be wrong. Even if you do it like 90% right, just one little mistake will make the whole thing incorrect. So to do this really carefully, we're just going to do one little step at a time. And the first thing we do is we always do exponents. You guys remember PEMDAS? So do exponents first. So we're going to do those exponents. And so negative 1 squared, let's think about what this negative 1 squared is. Negative 1 squared means negative 1 times negative 1. And a negative times a negative make a positive, so that's going to be positive 1. So let's go ahead and just replace that with positive 1. Everything else is going to stay the same. So the 3 stays the same. This stays the same, this stays the same, this stays the same. All I'm doing is I'm replacing this with a positive 1. And the reason, again, is because negative 1 times negative 1 is positive 1. Now, the next thing here is to do multiplication. So we're going to do multiplication. These parentheses really are just stand-ins for multiplication. That's why we're treating those parentheses as multiplication. So multiply those guys. We multiply those guys. 3 times 1 is 3. Negative 2 times negative 1. A negative times a negative, that makes a positive. So we got a positive 2 plus 2, and the answer will be 7. Okay, so not hard in the sense that like the idea isn't hard. You just have to be really careful with your negative signs. Let's do this one. Negative 2x squared minus 5x plus 3. And wherever you see the x's, you're going to replace those with negative 7. So let's get this guy set up and then pause the video and see how you do on this one. Okay, so first thing you got to do, just do one little thing. We're going to do that exponent. Negative 7 times negative 7 is positive 49. And then we're going to keep the rest exactly the same. I've just done one simplification. Now it's time to do the multiplication stage. Multiply those guys, that's going to give you negative 98. A negative times a negative will be a positive 35. And when you do that math, that's going to give you negative 60. Okay, so check your work and find out where you missed a sign, because chances are you messed up one of the negatives or positives somewhere in there. Okay, now let's go on to a couple easy questions. Let's say you've got some table like x and f of x, and I'm going to do one like, let's see, I'm not going to write the whole thing because it's just a lot, but we're going to 3, 53, 78, 82. So if it's asking what is f of 1, f of 1 is the y value when x is 1. I could write this is the same thing as f of 0, this is f of 1, this is f of 2, this is f of 3. So f of 1 is 53. If it's asking what is f of 3 is going to be 82. And I didn't write, let's see, f of 8 will be 30. So f of 8 is 30. Okay, that one's easy. Let's do this one. You've got this graph, and it looks something like this. And the question will say, let's see, 1, 2, 3. The question will say, what is f of 1? So f of 1, you go and when the x value is 1, this is an x value. When the x value is 1, you go and hit your graph. And then when you hit your graph, you go back and check. That is going to be at -3. So f of 1 is -3. What about f of 2? If I go down here till I hit my graph, and then I go over here, that's -1. So f of 2 is -1. F of 3, I want you to think about this on your own, and let's check our answer. All right, if you said f of 3 is 1, that is exactly right, because this will be 1. And again, if you're looking at your piece of paper rather than my video, that makes a lot more sense why that was 1. Okay, let's go down now, and last question is writing equations for things. So you've got your table n and f of n. You've got 1, 2, 3, -33, -52, -71. And we want an equation, and the equation is going to be useful in case we wanted to find like the 17th term or the 170th term, right? It's going to allow us to see far into the future by extrapolating this pattern forward. So the way to do it is with this formula. F of n equals blank n plus something. And what goes here is the common difference. And what goes here is the 0th term. So the common difference here is, each time I'm going down, is going to be -19. -19. So that's the common difference, is -19. And the 0th term, if I worked my way up here, the 0th term is going to be -14, I think. And so that's your equation, -19n plus -14, which you could write as -19n minus 14 would be a better way of writing that. Okay, now the other part of this is we also have to have a recursive formula. And the recursive formula will be in this format. F of n equals f of n minus 1 plus the common difference, and f of 0 equals something. Now this and this will be the same number, and this will be the same number. What that means is starting from -14, you add -19 to get the next y value. Or in other words, to get the next y value, you subtract 19 from the preceding y value. Okay, that's linear. Let's do one example of exponential. Exponential is this. You've got this example. We got 1, 2, 3. And then we've got 12, 36, and 108. This is n, and this is f of n. Okay, so same kind of deal. Our formula for this one is a little bit different though. F of n equals blank times blank to the n, and f of n equals f n minus 1 times blank, and f of 0 equals blank. So what goes in here is the 0th term. What goes in here is the common ratio. Common ratio here is 3, so that goes there. And this one will also go in here. And the 0th term, if I work my way up the table, my 0th term is going to be 4. F of 0 literally means the 0th term. This is f of 0. This is f of 1. So 12 is f of 1. 36 is f of 2. So f of 0 is 4, kind of by definition. Okay, hope that's helpful for you guys. What I would recommend is going now onto Canvas and doing Unit 5 test review and just doing those questions over and over again. The more you repeat them, the easier they'll become, and then you'll be really confident as you go and take this test. Good luck, guys. Bye.